mostly just so that we had a clear picture of what it looked like out there. But you're absolutely right. It's certainly either import or the use of it as a tool in their agriculture. Sure, there's lots of countries that don't allow it. Absolutely. Yep, for a variety of reasons. Yeah, it's really a dividing line there between which of the GE products are on the input side, they're influencing how we grow the food, versus those much smaller number of genetically engineered crops that you could genetically engineer it so that it has more of this vitamin or it has more of this healthy fatty acid, those kinds of things. If you look at those as a class, those don't have anything at all to do with pesticides. Those are output traits that might have nutrition and health impacts. But when they do that, so let's say it produces more vitamin X, that is something totally different than over here where the plant is actually producing a pesticide because we engineered it to produce a pesticide. So they are literally categorically different from each other. They tend to be different sets of crops. So like I showed the slower browning apple, right? There are no genetically engineered apples that are producing pesticides. In fact, the only genetically engineered apple is the non-browning apple that I showed you. So it's totally separate from the whole question of managing the crop and using chemicals. And it is about what compounds are in it that either influences the way that it looks or the way that we would consume it. Like if it has more of this vitamin, which might be a good thing. So those are two, literally they're almost 180 degrees because one is about how you grow it and the other is about how it's used that way. So input traits versus output traits is really the best way to think about that. And output traits are not pesticidal. That's what we do on farms, is try to control organisms. Yep. And apples, the question was about like generations of apples that are genetically engineered. That would be true, but we don't generally reproduce apples from seed. We do it by grafting, right? So they produced, what do they call the top part? The scion, right? Yeah, and grafting is like magic. I don't understand it at all, but it works. Anyway, they produced that material that they could graft with that they had edited. That, yeah, sure it would. Yeah, and I didn't talk about this because it's maybe a little too much detail, but when we're talking about genetic engineering, it means that we changed something. We either inserted a gene or we edited the gene, and then that now is heritable. It will go from one generation to the next. It is a stable change in genetic material. It's not just one generation. It is ad infinitum. That we would genetically engineer it, and this was very much like a corporate control kind of thing, so that you absolutely must buy this. And the way we would do that is that after it reproduced once, it would shut itself off and it would be sterile. So there was some of the original science around what came to be tagged as Terminator genes, was never commercialized by any company. And I think the industry as a whole, because of the backlash against the very idea of it, would not, they're not pursuing it from a science side. So it's not like they're necessarily hiding it. It's that the agreement is that that's not a path that we as a society want to go down. The Terminator is a GE, not that I know of. No. It depends a little on which studies we're talking about. So if there's studies being done that are part of the regulatory process so that it can be approved, if it needs approval by EPA or FDA or whatever, then most of that is funded by industry, but it doesn't necessarily mean that it's done by industry. And that's been true for a long time, not only with GE technology, but with other technologies. Some of it gets done at kind of contract research, some of it gets done at universities, those types of things. So the questions around like what's the ecological impact of a certain technology in a certain area. Some of that gets publicly funded through research grant programs through USDA, but potentially also the National Science Foundation and maybe a couple of others. That gets done by academics, gets done by university researchers, some at public institutions, ag universities, and some not. So it does depend. But for the regulatory process, that burden is on the companies that want to have products registered. I mean, we've selected wheat for a long time for a lot of different things, but the fact is, I don't think there's anywhere in the world where you can commercially buy genetically engineered wheat and genetically engineered in the way that I described it, where it's either a transgenic organism. So all the differences in wheat are a result of what we might call classic plant breeding. So there was some development of Roundup or glyphosate resistant wheat that started in the 1990s, and the industry, like the wheat industry, like the millers and bakers actually pushed back and said, we don't want that. So you can't put the genie back in the bottle, right? So the technology still exists, but in a commercial sense, it's not available anywhere on Earth right now. Yes. That practice would be much newer than the debate in the 90s, which was about should we have wheat that is similar to what we just did with corn and soy, which is to put the gene in it, not so that you could dry wheat at the end or desiccate wheat at the end, but so you could control weeds in the wheat early in the season. Yeah, because it's not tolerant of glyphosate, and we don't have genetically engineered glyphosate tolerant wheat, but that doesn't mean that glyphosate is not used in wheat production. It's used in the production of a lot of crops, as it has been for decades, prior to 97 and 98. So it's been out there for a long, long time. The situation with BT is somewhat different than it is with, for example, Roundup, where now we have, it must be approaching a couple of dozen weeds that have evolved resistance, and we talked about that in our report at some length, and which is connected to genetic engineering, but is actually a pesticide question. And organisms will always evolve resistance, and it might take a year or it might take 200 years. The development of resistance to BT from crops that contain that gene, I'm trying to remember if there's any well-documented instances of that. There has been some resistance where it was actually used repeatedly as a spray, so you're actually applying the protein. And the person who chaired our committee, he's an entomologist, a bug scientist at North Carolina State, who's been involved in this issue for decades, and knows a lot about it. We were talking about this as a committee, and he made the comment, and I didn't realize this, that decades ago, they basically look at BT as a public good, which means that they have really pretty good management plans to at least dramatically slow down the development of resistance, where when the herbicide tolerant ones came out, there was plans out there, but there was no evidence that anybody was actually following them. So it's actually the two categories have been treated differently, and the result of that is that BT is still pretty robust. And it's also not a single protein. They're called cry proteins, cry for crystal, and there are a whole bunch of them. And it's possible that an insect would evolve resistance to one of them, but it doesn't cross over to the rest of them. It's that specific. So eventually it will happen, because that's what happens out in the world, right? But it's, considering how widely used it is, it's been much less of an issue than some of the development of herbicide resistance for certain categories of weeds, broadly speaking, over the last 20 years. I wouldn't say that we ignored this issue. I mean, as I said, I'm an agronomist, so I'm not necessarily qualified to look at all of those issues, but we had people on the committee that were qualified to look at those issues. And, part of it is just at kind of the basic level is how big is the change that we're making within, the crop that does not have the trait and the crop that does have the trait. And something like glyphosate resistance is a very small change that allows the plant to still produce a critical amino acid. And as I noted with the picture of the brassicas, there, even within a species, different plants turn on and off genes in different ways. And again, we were interested in, is this within the scope of what we would normally expect because plants are different from each other, or is it something that is truly novel? And most of the genetically engineered crops up to this point are not particularly novel. You could say that BT is, but again, we already knew about BT and we were already using BT. I think it's perfectly safe I think it's absolutely not safe. And we listened to them and we read the original papers. So, it comes to a point where, you do what you can do within the context of what you're asked. And we felt pretty comfortable that, in fact, we had done that. But I want to respect the fact that there's a lot of uncertainty in this issue and in almost any issue. And again, the idea that, like, if I just bring a bunch of facts that I can convince you that no, it's either really good or really bad, that's not the way that I'm going to approach this. It's like people don't have to agree with me and they don't have to agree with the committee, right? But we were asked to do certain things, and then we tried to be pretty transparent about here's how we did it. And brought in, more so than usual, a very, very broad range of perspectives, some of which were scientists, but some of which were not. It's like, how do you communicate about science, and what do people care about? So we looked at all of those issues as we went through. Yeah, there has been some longer term, but they're still animal studies, but they would be what you might call multi-generational studies, some of which were controversial studies. And we actually talked to some of those scientists as a committee. If you're looking at it from a regulatory standpoint, the regulations say that the company that's applying for some kind of approval needs to do certain things. And the regulatory structure can't arbitrarily say, it says you're supposed to do this, but we really want you to do 5 times that. That can't be done under the regulatory structure. You have to change the structure. You have to change the regulations to be able to do that. So yes, we had many people that said we should do longer term studies about how it affects ecology. We should do longer term studies about how it affects animals. It's all true, but to do that, you'd have to change the structure. There has been at USDA and EPA like working groups thinking about, do we need to change the fundamental structure about how we govern genetic engineering? I don't know where that is right now. They were actually working on it when we were working as a committee. And it would be the possibility, for example, that they would regulate based on novelty rather than on process. Did you get here by conventional plant breeding or did you get here by genetic engineering? So I honestly don't know the status of where the regulatory structure is. My guess is it's moving very slowly. Yeah, just a guess. I'm of 2 minds here. I don't think that there's currently a push to do a federal label unless somebody knows something different that's here. Okay. I also am a little less excited about the idea that the only way to get to labeling is that we have a federal regulation that says you must do this. I've actually talked to some companies, and I'm talking about food companies now, that I think it may come from the consumer side of the equation rather than the regulatory side of the equation. That, it depends on what the label says, of course, but a lot of the food companies really wouldn't have a big problem if the consumer wants it labeled, can we label it? So I don't know which of those might come to pass eventually, but I do think that there are multiple pathways that we could get to fairly broad labeling, one of which is, a federal act, a bill that passes and is signed, and then the other one is through the marketplace. But some consumers, and the industry is starting to react to that. That's my point, is that we could get there and not have a law passed that says you have to do it. We'll see. I have no idea which way it's going to go, but they are two pathways. Well, and if they passed a law, then the law, let's just say they passed a law and the law says they have to be labeled. And then there is the entire process that 5 years down the road makes the decision about what does the label actually look like and say, and does that have any influence on the decisions that consumers make? Those are totally open questions. We actually don't know the answer to that. Could be yes, could be no, could be maybe. Don't know. But we'll see. I agree that there's like a plethora of labels out there, right? You could buy a bar that has 12 labels on it. Yeah, absolutely. It's like label saturation. So, yeah, okay. Okay, I've kept all of you long enough. Thank you.
Bye.